Hi, in today's video I would like to introduce you a very nice problem of Bulgarian Mathematical Olympiad edition 1986. Here is the following information. Determine all n as an integer number such that we have this following condition: 3 to the n plus 88 is a perfect square. Okay, in fact this is very beautiful problem, but it's full with tricks. So anyway, so the hint that I'm trying to give to this problem, just try to factor out these two terms, make it as two sides of the equation and extract the multiple of both sides and use the arithmetic rules in order to solve it easily. Okay, and consider the cases. Okay, go ahead, pause this video if you would like to give it a try to this problem. When you come back to see the full solution. Okay, let's get into the solution. So we have 3 to the n plus 88. In order to have this term as a perfect square, I'm going to set this one equals to m square, where is the m as a sum of natural numbers. Okay, before I start solving this one, I'm going to check the parity of this one. If you take a look carefully, 3 to the n is a odd. Okay, 88 is a even. That's mean the left hand side of this equation is a odd. Okay, since the left hand side of this equation is odd, that means the right hand side of this equation is odd as well. So this is odd, implies m must be odd. So now I'm going to factor this one out by using the trick. So this one, 3 to the n plus 88 is the same as 169 minus 81, okay, equals m square. I'm going to move over 169 to the right hand side of this equation and leave 81 as is it. Okay, so I will get here 3 to the n minus 81 is the same as 3 to the fourth, okay, equals m square minus 169, which is equals m square. So 169 is the same as 13 quinary square. Okay, then I'm going to put this 3 to the 4 as a common factor for the left hand side of this equation. I will get 3 to the fourth is multiplied by 3 to the n minus fourth minus 1 equals m square minus 13 square as the same as m minus 13 is multiplied by m plus 13. Okay, now I'm going to check the parity of this expression as I have here. I'm going to check the parity on the right hand side of this equation. As we said before, m is a odd, that's mean m minus 13 is a even. Okay, and also m plus 13 is a even as well, because odd minus odd is given as even, or odd plus odd is given as even. Okay, that's mean the left hand side of this equation is a even as well. Okay, but 3 to the 4 is a odd, but we need to continue factoring out this one as well. Since this is odd, so we need to factor this one out to extract the evenness. So this one, 3 to the fourth, this one is giving me 3 minus 1 factor. I'm going to factor out this one. It's giving us 3 to the n minus 5 plus 3 to the n minus 6 and so on and so forth until you get 3 to the 1 plus 3 to the 0, which is 1. Okay, equals m minus 13 is multiplied by m plus 13. Okay, now if you take a look carefully, since the right hand side is even, that's mean the left hand side of this equation is even as well. So we have this term is 2, 3 minus 2 is 2, so that's mean I have 3 to the fourth, which is 81. 81 is multiplied by 2, which is 162. I'm going to break this one into 3 cases. Let's check the first case. When we have n strictly superior than 4. Okay, so for all n strictly superior than 4, I'm going to calculate the difference of these two terms, m plus 13 minus m minus 13. This one is giving us 26 which is 2, is multiplied by 13. Because m will be cancelled out, I will be left with this number. We have the linear combination here. So the linear combination of two integers is a multiple of their GCD. Okay. In addition, since we found 2 is multiplied by 13 as a result, that means m plus 13 and m minus 13 both are shared number 13 as a common factor. Let's write down that. By using the Kangaroo's definition, this one is telling us the product m plus 13 is multiplied by m minus 13 is a congruent to 0 mod 13. Okay, here is the first statement. Since we have equality and we have these two terms even, we have this number is even as well, 162. So this number, as we found before, 2 is multiplied by 3 to the 4th, which is 162. Okay, and we found also right hand side of this equation is a multiple of 13, but 160, which equal 3 to the 4th, which equal 2 is multiplied by 3 to the 4th, is not a multiple of 13. So this one implies the left hand side of this equation is a multiple of 3. By using the congruency rule, I will get this expression. I will get 162 is multiplied, let's call this one as a capital A, is multiplied by capital A, is a congruent to 0 mod 3. Okay, since the right hand side of this equation is a multiple of 13 and the left hand side of this equation is a multiple of 3, which is ridiculous. Okay, that means we have no solutions of this equation when we have n strictly superior than 4. Okay, so no solution for all n strictly superior than 4. Now let's move on to the next case. Now I'm going to do the case when we have n strictly inferior than 4. If you take a look carefully at the left hand side of this expression, I have n strictly inferior than 4. This implies n minus 4 is strictly inferior than 0. Okay, by using the exponent rule, I get 3 to the n minus 4 is strictly inferior than 3 to the 0, which is 1. I'm going to bring this one to the left hand side of this inequality. It's giving me 3 to the n minus 4 minus 1 strictly inferior than 0. Okay, that means we have this term is negative, but we know m plus 13 is a positive number. So since we have this a positive, that means m minus 13 is a positive as well. So the right hand side of this equation must be positive, but we found the left hand side of this equation is negative. So we have a contradiction. This is impossible. What does mean? That means no solutions, all n strictly inferior than 4. Let's check the last case. The last case, when we have n equals to 4, I'm going to plug number 4 into this exponent to see what's given us. 3 to the 4 is multiplied by 3 to the 4 minus 4 minus 1. I'm going to simplify this one more. This one is giving me 3 to the 4th. This one is giving me 1 minus 1, which equal to 0. Okay, equals to this term, the left, which is on the right hand side of this expression. So equal to m minus 13 is multiplied by m plus 13. So this one, I'm going to distribute this one. This one is giving me m square minus 13 quinary square equals to 0. Okay, this one is giving me m square equals 13 square. Okay, now we found a perfect square. So we found n equal to now we found the only solution of this equation, n equal to 4, is giving us a perfect square here. I'm going to plug this info into the expression to see what's given us. It will have 3 to the 4th, as we found before, plus 88. 3 to the 4th is 81. plus 88 equals 169. 169 is the same as 13 quinary square, which equals to m square. Okay. Finally, only the solution that we found, n equals 4. Okay. I have proven this one successfully. If you have any question or suggestion, just put it in the comment section below. If you are interested in watching this one, don't forget to support us with your like and subscribe. Thank you for watching. I will see you in next video. Bye.